right, guys. Hey, welcome back. This is part 2 of solving a system of 3 equations with 3 variables, okay? If you recall, we came up with solutions for a straightforward, nothing weird type of problems. We talked visually what all 3 of these look like, okay? If you remember, each one of these represents a plane in 3D space, and we're trying to figure out what all 3 of these planes intersect at, specifically a point. And think of a plane as an area of answers in this 3D space. So we're trying to find where all 3 areas really intersect at, okay? Today's video is we're gonna look at what happens if we have an infinite or no solution, okay? And we're gonna see what this looks like graphically as well to prove what we're seeing algebraically. So here's my system that I'm gonna start with here. Okay, this is our third example. And I'm going to mark what each equation is. So this is my first, my second, and my third, just like I did in class. So we want to eliminate a variable, all right? And it doesn't really matter what variable you want to get rid of first. What about x? Let's get rid of x. And what I'm going to do is I'm going to take the first equation, I'll multiply it by -3 and add it to this guy, and the x's cancel. So I'm going to multiply equation 1 by -3, and I'm adding it to equation 3. So I'm adding that little note so I know what I did, okay? So here we go. I get -6x minus 3y plus 9z equals -15 after I multiply. And then this one I just put right underneath because I'm going to add to it. Cool. Now notice something. X's cancel, Y's cancel, Z's cancel. I get 0. These guys cancel, I get 0. And usually by then we say, oh, you know what, infinite solutions. And we're finished. We're done. Not in this video. All right, we're going to talk about what that means, okay? So let's go back to the original system for a second. So I can see that the first and third equation look very close to each other, right? If I multiply this just by 3, I get the same equation down here. So that means that 1 and 3 are the same plane, okay? Let's write that down. Equation 1 and equation 3 are the same plane. Okay? They're the same. Okay, so that means this system, which had 3 planes to start, is actually 2 planes, okay? And if you remember from your geometry class, which I hope you do, when 2 planes intersect, they intersect at a line. So that makes sense. If a line is where they intersect, then yeah, there's going to be infinite solutions because a line is infinite in both directions. Okay, so here's what I propose that we do. Let's figure out what that line is, okay? Let's come up with an equation for it. So since I know 1 and 3 are the same, I'm not going to use them again, obviously. Equation 2 is the other odd plane that I want to work with. So let's figure out its intersection. So what I'm going to do is I'm going to take both of these equations, 1 and 2. I could have chose 2 and 3, doesn't matter. So I'm going to take 1 and 2 and eliminate the variable x again. So I'm going to multiply equation 2 by a -2 and then add it to equation 1. Okay, and let me just put the camera down a little bit so you can see everything. So let's multiply this by a -2. So that's a -2x minus a 4y plus an 8z equals -14. And then I'm going to just put equation 1 right underneath it, and we're going to add them. Oops. No. Minus 3z equals 5. Okay. Alrighty. So the x's cancel. This becomes a -3y. This becomes a positive 5z. And this guy over here becomes what? A -9 for that guy? something like that. So here it is, okay? So this is the line they intersect. That the two planes intersect at, okay? So that's why we're showing an infinite solution here. Now, I don't want you to take my word for it. Let's look at it graphically. So I have a nice handy dandy calculator. All right, so let me just put that up on the screen here. Oops. As long as this, there we go. There's the calculator. Okay, so here's my 3D space, my X, Y, and Z axis. And let me type in these equations here. All right, here's my first one. So here's what the plane looks like. It's light blue, okay? I'm gonna take the third equation in, see what happens. It should be the same, right? That's what we discovered. They're the exact same plane. Yep, and as I was typing it in, you kind of see when it was shifting it, but look, it became darker, okay? That's a darker blue. So we were right. When we said they were the same, it truly is. So this equation, or I'm sorry, this system only had two planes in it. Let's look at the final one. And hey, voila. I don't know if you guys can see that, but look, those two planes are intersecting. You guys see that? How it crosses? Oh, that's such a cool looking shape, or cool looking picture. And that intersection line is where all my answers are to this system, okay? So anything I plug in, as long as it matches that line, I'm good to go. So there it is, okay? So that means, if I take a look, this line is where all my answers are. That's why it's infinite solutions here, okay? Does that make sense? I like showing the visual aspect behind it because I think it really proves what the algebra is saying. Okay, we got one more to go. So let's erase all this. Let's try one more example problem. And spoiler alert, it's a no solution one we're gonna do. But the important thing is, what does it look like visually if it's no solution? All right, that's what we're gonna look at here. So let's see, that one is this guy. So 3x minus y minus 2z equals 4. 6x minus 2y minus 4z equals 11. 9x minus 3y minus 6z equals 12. Okay, so there's my next problem, okay? And I'm gonna pick a variable to eliminate, and x just looks easy for me. And that's just by preference. So I'm gonna go ahead, I'm gonna eliminate x for us. And what I'm gonna do is I'm gonna multiply this by a -2 and add it to this guy, okay? So I'm gonna multiply equation 1 by a -2, add it to equation 2 to help get rid of the x's. So far, nothing looks weird about this problem, unless you guys are seeing that already, that there's something quite not right with it, and if that's the case, nice, very good. So we got -6x, positive 2y, positive 4z equals -8. That's after I multiply this by a -2. And then I'm gonna put this underneath it for the ride, for the fun. Boom. All right, we're gonna add these together. X's, gone. Y's, gone. Z's, gone. Yes, you have to do the sound effects or this math won't work out, okay? So when you're watching this video, you better be doing that. And on the other side, we get -8 plus 11 gives me a 3. Uh-oh, that doesn't work. So usually when you see that, everyone says, no solutions, and they move on. But not us. We're gonna actually look as to why is this no solutions. So if you remember back when we did a system of 2 equations with 2 unknowns, no solutions was a set of parallel lines, right? Don't you leave this video. That bell wasn't for you to leave, so don't you dare. So there were parallel lines. That's what was no solutions. So maybe we have parallel planes in here, okay? But we have 3 planes. So we could have a set of 3 planes all being parallel. Or, I don't know, can you guys see it? Do you see 2 equations that are the same plane? Did I do this again? I think I did. Look at this one, and look at this one. If I multiply this by 3, don't I get the bottom equation? I do. So once again, equation 1 and equation 3 are the same plane. Hooray! So now the question becomes, out of the 2 planes that are in here, okay, are they parallel to make it no solution? Because if there's only 2 planes, it's either they intersect, which that intersection is a line, which is all your answers, or they're parallel to whether there's no solutions for any of them, okay? So let's look at this visually. I'm gonna go ahead and pull up the graphing calculator, the 3D graphing calculator, however you wanna call it. So say goodbye to these guys. So long, farewell, maybe to say goodnight. Sound of music. Here we go. So we have 3x minus y minus 2z equals 4. So here's our first plane on the graph here. There it is. Looks very nice. Lovely. Okay. Now, I'm going to graph equation 3 next, and that plane should get darker in color if we did this correctly, because we said 1 and 3 are the same plane. Here's crossing our fingers. Ta-da! It got darker. So yeah, 1 and 3 are the same. So now we got to see if these guys are parallel. Uh-oh, I have a knock at the door, so hold on. You're going to see a quick cut in the recording. Okay, sorry about that. I had to let a student into my classroom so he can get his iPad. Okay, so let's go ahead. The last equation. And if we're correct, fingers crossed, if there's no solution, these better be parallel. Ta-da! They're parallel. Hey, we were correct. There's nothing worse than making an assumption and being incorrect. But that's not a bad thing, okay? That just means that it's something else, okay? But in this case, we were correct. So this system of 3 equations is actually just 2 planes, not 3. One of them is the same, right? And they end up being parallel. So these are actually parallel planes, okay? Awesome. So that's just one case. I mean, you could have another case. I'm going to look at it from the side. I can't draw planes in 3D, but let's say you had 3 planes intersecting like this. You could see where 2 of them are always intersecting, a combination of 2, but not all 3. So that could be like another situation where there is no solution. There's intersections, but not all 3 are going to work. And by graphing, we can visually see this, okay? So equation 1 and 3 are the same plane, and the 2 planes are parallel. Boom. That's why it's not working, okay? And that's it. So I hate just giving you the algebra and say, oh, this means no solutions, or this means infinite, without showing you visually what that is, okay? Since we know these are planes, why not use that visual interpretation to support your equations here, okay? So there we go. There's part 2 of the video, okay? I like this stuff. This is a lot of fun. So part 3 is coming up. We're going to do a word problem, so it's not going to be that long of a video. And then that'll be it for systems of 3 variables, okay? So stay tuned for the next video.